Hello. This is kind of sort of a continuation of video 14 because we're still talking about oilfield.cpp, but this is 15 and I put it off so that we could focus and concentrate on what the hey is going on in file oilfield.cpp starting at line 101, the overloaded assignment operator. I don't think we've seen the likes of this before. You know what? Before I even dive into that, I'm going to start with a figure. Let's say the left-hand side of the assignment operator is this object right here. And it has a grid and all that other stuff, but it also has rows and columns. And maybe we read a region earlier, I don't know, I don't care. But maybe rows in that case was 12 and columns was 15. I'm just making that up. And I'm going to call this the home object. This is the object that we're inside when this member function is called. Home object. Home is where the heart is. Now, you may have noticed, if you've opened this file in a language-sensitive editor, that the word this changes a special color. It's a reserved word. Pardon me. The word this, by default, is a pointer of type pointer to whatever kind of object I'm inside. Yeah, it is that messy. What does it point at? It points at the object that we're inside. It's hard to describe this. We get that for free. When we call any member function whatsoever of this oil field object, we call any member function, we could use this pointer without defining it, without declaring it, without doing any dynamic memory allocation, no nothing. The system provides this for us so that we can talk about ourselves, so that we can look at ourselves, so that we can refer to ourselves. I'm this. We get that for free. This is a pointer. This. See, I told you it's hard to describe this. This holds the address of the object that I'm inside when a member function is called. I'm repeating that for emphasis. And that's the home object. Now, that's our home object. There is also another one. Other is another oil field object. This is going to be, in our overloaded operator, that's going to be the one on the other side of the equal sign. So when we call, let's say we've got oil 1 equals oil 2. This is up in the main program. Oil 1 equals oil 2. How can such an innocent looking little assignment statement cause us so much headache? Well, watch. This is oil 1 right here. The left-hand side we call a member function. Operator equals is the member function. We're inside this an object right here. This, oil 2, that's the away object. Now, they don't know what their names are in the outside world, which is actually why we have to have the this pointer. It doesn't know its name in the main program as oil 1. Strange as it may seem, all the information that this object has, it does not have what its variable name is in the outside world, that big scary outside world. This one doesn't know either. This was passed in as a parameter, and the parameter is variable other. Now, watch this very carefully. Here's this. That's a variable that I can use to refer to this home object. Put a circle around it. This is the focus of attention. This is the object that I'm inside while this member function is executing. That's the away team over there. The other object, other, is a variable name which is not a pointer. So, if this object, this entire oil field object lives at hex 1000, why not? I'll make that up. And maybe the other object, that lives way over there at hex 7000. If I want to see that 7,000 on the screen, I have no idea why I'd want to do that. Then I would have to print out the address of other. Because other is a reference to this. It's not a pointer to it. References and pointers, even though they deal with hexadecimal numbers, they do it in different ways. The address of other is hex 7000. The value of pointer this is hex 1000. I left no room to put it in there, but I squeezed in a tiny little hex 1000. That is the value of variable this, which is a pointer variable. Why am I making such a big deal, for crying out loud? Line 102. Violated my convention. There, line number 102. This is comparing addresses. Compares addresses of oil field objects. Line 102, I hope I got the light right. Yeah. Line 102 is comparing two different hexadecimal values. It's not comparing whether this well, you know what, this has rows and columns as well. Let me fill that in. Rows, let's use our earlier text example. Rows, columns. That has its own rows and columns, private variables. The one that we're inside, on the left-hand side, oil 1, known as oil 1 in the outside world, unknown name on the inside world, that has its very own rows and columns. Where was I going with that? Oh, we're not comparing this whole object to this whole object. We can't even do that unless we have overloaded the double equals operator, which we have not done. There is a limit to how complicated I wanted to make this program. We could have done it, but we didn't. So what are we doing? We are comparing to see if, let's see, if this equals ampersand other. Let me read that out loud. If the value of variable this is exactly equal to the address of other. Look how why we did that comparison that way is this. It's so hard to use. I wish they had used a different name than this for that variable. The value of variable this is the address of this object. To get the address of other object, we're going to have to put an ampersand out front. We are asking, is hex 1000 equal to hex 7000? Oh, silly, of course it is not. Why would we even bother with such a thing? Well, even though it wouldn't make any sense, a foolish programmer up in the main world, the outside world, they might have written this. Oil 3 equals oil 3. That's not a syntax error. The compiler won't stop you from doing that. Take oil 3 and copy it to oil 3. Well, finally we get to appeal to common sense here. If I'm copying an object to itself, it's not going to change. It better not. If I copy an object to itself, if this, the value of this pointer, is exactly the address of the other one, that means that we've done something silly like this. We passed an object as a parameter into itself in the overloaded assignment operator. And there's nothing to do. No copying. I don't need to copy rows and columns and all that. They're already copies of themselves automatically. Then what's the return all about? Return the address of this. You know what? That's kind of a convention. I'm sorry, I said that wrong. Take that back, erase that. 103 is not return the address of this. Return what's pointed at by this. Look at the return type of that operator. We're returning a reference to an oil field. I'm going to do some hand waving. I haven't done that in a while. I'm going to wave hands and say, just remember to put a reference to the object out front and remember to turn what's pointed at by this if we've got a clone. And actually we've got to do it at the bottom as well after we're done copying. Just remember to return what's pointed at by this. Why do we do that again? Again, to accommodate weird syntax is probably not a good idea, but it's not illegal to do this. Oil 1 equals oil 2 equals oil 3. That's what we're accommodating by returning a reference to an oil field object and by returning what's pointed at by this. When we return what's pointed at by this, we're returning a reference to an entire object, and that's what will happen when this particular function call, remember that's a function call all by itself, that calls a member function on the oil2 object to copy everything that's in the oil3 object into the oil2 object, and when it's done, it returns a reference to the oil2 object. Why? So that now we have a parameter that can get passed into the first call over here on the left. It's actually the second one that occurs. It's going to evaluate all assignment statements from right to left. So it starts over here, copies oil 3 to oil 2, all done, done and done, returns a reference to oil 2, and now that reference becomes the right-hand side of the next assignment operator to execute, which is going to copy oil 2 to oil 1. That's kind of advanced stuff, and I'm sorry about that, but it is a convention to accommodate that by returning a reference to an object that you just now copied. Okay, that's a lot out of just a few lines. Let's get the ball rolling. 104, deposits. Well, remember, I'm inside this object right here. Oh, I didn't show deposits. I'll abbreviate. Deposits, oh, I found 9. That was a big field over there. Deposits over here. Maybe it's just 2. Whoops, I've already got 2. 1, I only found 1 deposit. Now then, now back to line 104. Deposits equals other dot deposits. Now other dot deposits, that we can figure that out. Other dot deposits, that's 1. On the left-hand side, we put it into deposits, so it's going to copy over the 9 with a 1. Let me say that again. Line 104. On the right-hand side, other dot deposits is the deposits variable in the other object that got passed into our overloaded assignment operator. We can make a copy of that, 1, and we store that in deposits without any qualification out front. Let me put this on here. Line, which was it? 104. I'll make a note. This is exactly equivalent, EXACTLY, to this. This arrow deposits equals other dot deposits. You don't have to use the this here, but you can. The this as a pointer to the object that I'm inside. So I could have written line 104 for emphasis to say I'm copying the other deposits into this deposits over here, this arrow deposits. But I don't actually have to have the this arrow because this is not ambiguous. It knows exactly which deposits I'm talking about if I leave off any qualifier out front. Okay? So that's to explain the syntax on 104. What that does not explain, and you might be screaming inside your mind, even though not out loud, is, I thought these were private variables. I thought those were untouchable. How can I get that without going through an accessor? Weren't you screaming that inside your mind? I know you were. How can I get a hold not only of deposits, but look at that, 105, 106. I am grabbing the values of those private variables over there in an object that is not me. And that should alarm you. Maybe it does now if it didn't before. I almost feel like I should erase the whole board to write this up here. But here is a big note that applies to all 3 of those assignment statements in shocking blood red. Protection. I'm going to put this in quotes. I'm going to make it look sacred here. Protection. And that means limited visibility of the private variables. That's what protection means in this context. Protection is at the class level, comma, not, double underline, the object level. And that's so surprising, I'll put an exclamation point. You want some protection? Here's some protection for you. This I'm pretending is up in the main program. Oil 1 equals oil 2. See out oil 1 dot rows. Oh, absolutely not. If this is the oil 1 object, oil 1 dot rows, that exists. It's right here. It's 12. The main program can't print that out. That's a private variable hidden inside this oil 1 object. And that's why perhaps you were alarmed that those assignment statements, which do work, are copying. I'll go ahead and do that. Let's execute those. It copies the deposits first, I did that. Copies the rows, that's 2. Copies the columns, that's 3. And yes, it can see those over there. So shook up, I'm dropping stuff on the floor. So what does this mean, close double quotes? This means objects of the same class, objects of the same homemade data type, can see each other's private variables. They're all one big exclusive club. I can see other dot columns, other dot rows, and all that because that's an object just like me. We're the same data type. We're both oil field objects. Two linked list objects can see each other's head pointers, cursor pointers, tail pointers, all that stuff if they want to. They've got to say which one they want to see. But it's to accommodate just this sort of thing. Being able to copy one to another, that would be a horrible mess. If it had to go strictly through accessors, it might not even be possible. Copy one linked list to another, we've got to copy the relative cursor position, and we can't do that if we can't see the other guy's cursor or the other girl's cursor. This has to be possible. Thus, this was a conscious design choice when they set up C++. You can't see private variables in any other kind of object. An oil field can't see the head cursor tail inside a linked list. But two linked list objects can see each other's private variables. Two oil fields can see each other's private variables. That's what this statement says. Protection is at the class level. Everybody inside the same class, they're all equally protected from the outside world, but not from each other. Then, where are we now? Well, look, that's a lot. I mean, it's almost a relief to get to just nested loops in a two-dimensional array, isn't it? When it gets around to copying the grid itself, look at this, 107 through 110, it's copying 0 to rows plus 2. And if you look back at the example that I erased, you'll realize that 0 through rows plus 2 is copying not only the region that was read in from the file, it's also copying that protective bouncy wall around it. So that's why it does start at 0 and continues on past rows plus 2, because that's going to copy. Same thing for columns. Columns equals 0, columns less than columns plus 2. That's copying the entire used part of the grid, which consists of the region read from the file with the bouncy wall of zeros around it. And the assignment statement itself, now that we know about protection among different objects in the same class, 109 shouldn't be terribly shocking. Just a sort of a review here, I could have written 109 as this arrow grid RC equals other dot grid RC. And the reason I keep doing that is to make sure that you understand the difference here between why we use an arrow in one case and a dot in the other. Other is an oil field variable. This is not an oil field variable, it's the pointer variable to an oil field variable. Okay. Good grief, that was a lot. Is there anything else? Does print have anything? Well, you'll notice print, when it prints it out, it's not printing out the bouncy wall. It's only printing out the guts of the inside of the grid that it read from the file. What? If grid, we're translating back the other direction. That's something to note. On line 124, I don't have room to write it, but you can write this down. Line 124, when it prints it out, is printing out the oil character. The char out front, I will write this on the board. What line is it? Line 124. Char. Oil char. Oil char was that enumerated value that doesn't have a data type. This is the @ symbol. We don't have to worry about that. Here's the deal, though. This is called a cast operator, C-A-S-T. The cast operator, we can actually use any data type that's been defined. We can put that out front. Almost, it looks like a function call, doesn't it? What we're doing is saying interpret oil char as a character type. We have to do that because it's an enumerated type. Oil char is not technically typed character. So when we print it out to the screen with our cout statement on line 124, we have to tell it, interpret oil char as a char. I could have said int oil char. That would also be a cast operator. What it would do is look up the integer ASCII equivalent of the @ character and print out that number. But since it doesn't really have, it's not associated with a standard data type, I have to tell the compiler, view what's in parentheses here just for this statement, view that as a char value as you're printing it to the screen. And that way it'll print out the @ character and we'll see it correctly. I don't know, these videos, just going through this source code, this has worn me out. You might be worn out as well. I'll cut you some slack. You know what, I think that's all of note in this so far, but I might have left out something. Look back through this code carefully, read through it so you understand what it's doing. If you understand this through and through, then you will be prepared for program 2, 2 and 2. Well, I'll see you online.